Hi, this is Dr. Ramu, Professor Head of Computer Science Engineering, Narsimha Engineering College, Hyderabad. Today we are going to see the data model. In the last class we have seen the difference between the database versus the file system. In the today's class we will see the data model. The data model is mainly it is going to abstract the low level data, means it is not going to display it is going to hide the low level storage structure, means it is going to give the clear clarity of the high level data description only, means so no need to worry about the minor things, and this is going to hide the data, right? And see the definition, the data model is a collection of high level data description constructs that abstract means hiding of something, right? Abstract the low level storage detail, because we no need to know the low level futures, got it? And coming to the database is allows user to define the and manipulate the data using data model. Data model is going to define the data in the better way to utilizing efficient way, right? And the importance, it provides a structure and organization of data, right? So it is going to give the structure of the data, right? When the data is in the structured format, right, you're going to understand the data very clearly. And also it is also going to organization to the data organization. And by doing these things we are going to simplify the database design and interaction also, got it? There are the six types of database models are there, right? The data models are the hierarchical data model, network hierarchical data model, network data model, entity relationship model, relational data model, and the object based data model, and the semi structured data model. There is a six data models are there. We will see one by one data model. The first one is the hierarchical. Hierarchical means is a kind of a tree structure, right? Already we have seen that the file system is which structure? Tree structure, right? And the organizing the data in tree like a structure, and with a root node and child nodes. For example, see, this is the root node, right? It contains a child nodes, and again is a kind of folders also, right? You treat it as a folders also, is a tree structure. This is called as a parent, and this is called as a child, child, right? And description one to one relationship means, for example, see, one parent you have a m number of childrens, got it? That is called as a 1 to m relation. And the advantages, real world relationships, right? Like take the app, your file system, or the website mapping, or the recipes is the real time example, right? So we are going to map 1 to n mapping. And coming to the disadvantages, so is a complex to implement, got it? And the lack of flexibility and structure changes are challenging, right? If you do any changes, it is not much easy as you compare with the other models. And coming to the deleting, a segment deletes all its children. For example, if you try to delete this one, right, this is going to give the error in for the below children's also, got it? This is the hierarchical model. And we'll see the next model is a network model. Network model is like that. For example, if we take the computer networks, right, there is a one computer is there, and one more computer is there, and you can take the computer, this is the computer. See how this connects, it is going to happen like this, right? And also this will connect like this and like this, got it? Here this is the network model. Network model is extends the hierarchical model with a group of structure. So in the network hierarchical model, it is a 1 to m, but here n to m relation. So describes the one to many and many to many also. That is the difference between the hierarchical model and the network model, and allows the records have a multiple parent nodes. Got it? Earlier we have only one parent node. Now we have a multiple parent nodes. Got it? And the advantage, handles a complex relationships effectively, right? And disadvantages, complex pointers under navigation, and the structure changes is impact the application programs, right? And the insertion deletions and updates are difficult. See, this is the network model. It is going to connect the multiple systems or multiple nodes. It is not much easy to manage the things. Got it? This way, these are all hierarchical model, network model. It is not feasible for the complex applications. To overcome that, we are going to the next model, entity relationship model. Entity relationship model is going to represent the diagrammatical representation. We'll see that in detail in the future lectures, right? And here the logical representation of data as a entities and relationships. Entity, what is an entity? Is real-time existence, real-time object, we will call it as a entity. And the relationship, right? See here, the entities and the relationships are going to make the visual representation of a data. And the components, it is going to entity real world objects, right? Like a students and teachers is called as a entities. And attributes is a kind of properties. For example, if you consider the student, right? Student is an entity, and what are the attributes for the student, right? Student has the name, and student has the what it is called roll number and age, right? These are called as attributes. And that how the students is going to connect with the teachers is called as a relationship. These are the three entities, attributes, and the relationships. And coming to the advantages, it's easy to build and widely used for the database design. See, please notice the database designing part, right? It is going to visual representation of a database. And coming to the integrated with the relational model. Yes, right? We are going to convert the ER diagram to the relational model. And no industry standards for the development and limited relationship representation. There is only, right, two relations are there, right? Like as a and easier relations are there. Association and aggregation relations. We'll see detail in the future lectures. And coming to the relational model, what we are currently using the relational model. Got it? And already we have gone through the relational model in the history perspective video, in the first video of this course. Here, they represent the data in the form of tables, right? The table contains that attributes, right? Attributes is nothing but the properties of the table, and the tuples, right? Each record, each row is called as a tuple, and the schema, right? Schema means it is going to define the how the one relation and one table is going to connect with the other table. It is going to duplicate by the schema. And the instance is the object of the given what it is called relation and data at the specific time. The specific time for the given record. Key terms, degree. What is a degree? Degree means it is going to define the how many attributes are there for the given entity. How many entities, how many attributes. For example, if you consider the student, it contains a roll number and age and what it is called address. If you consider these three attributes, the degree of student relationship student entity is 3 because it contains 3 attributes. Coming to the cardinality. Cardinality, it is going to define the how many rows for the particular table. For example, if you consider a table, it contains a 10 rows. Then we'll call it as a cardinality is 10. Right? It is the number of rows. This is the number of columns. Degree and the cardinality is important in the competitive exams point of view also. And coming to the advantages. See, the structure independent and the conceptual is simplicity. Structure independent, right? It is not going to depend on the anything. It is an independent structure and the conceptual simplicity, and support the SQL structure query language to extract or manage the data effectively, and the easy design and maintenance usage. Got it? And coming to the disadvantages. requires a powerful hardware and can leads a slower in the processing if a poor designed, right? We should design the database perfectly, then we are going to extract the data very easily. That is the advantage of the relational model which we are currently using in the MySQL, right, and the Oracle and other the database what we are going to use in the current trends. Got it? And the object data model. In the object data model, purely designed to handle the multimedia. See, the object-oriented programming with the relational database concepts, right? Components, object is called as a real-time entity. It's an instance of the class encapsulates the data and behavior. We should understand the here the database, sorry, object oriented designing models, right? Object abstraction, encapsulation, inheritance, right? So polymorphism, these are the things that are going to involved in the object oriented concepts. And attributes is called as a properties, the concept is same. Methods is going to behavior of the respective class, right? Class is a collection of similar objects. For example, if you consider that student class, if you consider the student class, and it has the objects like Raju, right, Ravi, right, and Ramu. These are the objects. So for example, here attributes are name, here name, and followed by the age. For example, if you consider these two attributes, Raju, for the Raju object, right, name is the Raju, and age is the, right, 20 years, right. Here the name is the name attribute value is Ravi, right, and here age is the 25, and here Ramu, age is the 35, and name is the Ramu. Got it? These are the differences, right? All these objects have the similar properties of the current class. Got it? Is it clear? And the classes and inheritance. Inheritance means that it is going to derive the properties from the parent to child, right? Sometimes we are going to say that you look like your father, right? Because the face similarities or your actions are like your dad, then you are going to, I mean, someone going to say that your looks like your father, right? That is called as an inheritance. It is going to inherit the properties from the parent to child, right? Advantages: real world modeling and the highly reusability, and the improved the reliability and flexibility, because we are going to handle the multimedia means if you want to handle the images, already we discussed in the first video, images and videos, we are going to handle this object oriented model. Disadvantages: complex navigation system under slower transactions, right, and the high system overhead, right, because definitely we are going to handle the images, right. Definitely this is a kind of burden is there in the system. And the semi-structured data model is a kind of XML, right, XML model, extensible markup language, allows a flexible data representation where the items of the same type can be different in attributes, commonly used in the XML representation. Please note this, right. Web-based applications, you are going to use this model, semi-structured model. Advantages: flexible and schema independent, and the portable across the system, because here it is going to used in the web-based. In web-based system, the web-based means it should be the platform independent, right. So it works in the Linux, Windows, and any other applications where you are going to use. Got it? And disadvantages: less efficient for the query compared to the SQL, right? When you comparing with the SQL, this is the not that much efficient. Now we are going to see the comparison of all these models. The structure of the hierarchical model, right? The structure of the hierarchical model, it is looks like a tree structure, and this is like a graph structure. There's difference. And here model, we discuss the entities, and relational model we have a tables, and here objects, and it's a flexible scheme. Coming to the relationship 1 to m to n, right? This is a entity model. We have a relationships are there, and relationships are there. There is a logical, and the relations of the relational model is a what it is called tables format in the complex and varied based on the dependence of the schema. and flexibility here low, right, and moderate. In the ER model, and here what is the relational model and semi-structured data, it is a highly flexible, right? Based on your needs, you are going to design your database model. In the complexity, when you comparing with all these, right, the relational model is a very low complexity. You're going to design or deal the relational model very easily by using the structure query language, right? This slide is going to explain the detailed features of all the 6 models which we are discussed in the today's lecture. Okay. And in the next class, we are going to see the levels of abstraction in the DBMS. Okay. Thank you.